Good morning, good afternoon, good evening, everyone. Welcome to today's ocean session by the Copernicus Marine Service, dedicated to teaching the ocean. I'm Marin Delorme, Training and Capacity Development Officer at Mercator Ocean International, and I will be guiding you through this webinar. Today, we will explore how operational ocean data, indicators, and tools made available by Copernicus Marine can support ocean literacy, education, and the development of engaging learning resources for students of all ages. Before we begin, let's quickly go over some house rules to make sure you enjoy the session to the fullest. Please don't use the chat box on your right-hand side for questions. It's there for greetings and for sharing links with participants throughout the session. If you have a technical or content-related question, we invite you to use the dedicated Q&A section. You can scan this QR code on the screen or click the Q&A button at the top of your screen to ask questions to our speakers. We'll have a Q&A session at the end of each presentation. And while you are on this part of the website, you will also see a poll about today's webinar. Feel free to fill it out anytime during the session. It helps us know what you thought of the webinar, any way that we could improve it. We will also send you a link to the survey after the webinar, so you can also fill it out later if you prefer. Finally, we encourage you to visit the guidelines and resources section of the event website. There you will find useful links to ocean literacy resources and to several relevant parts of the Copernicus Marine website, as well as links shared by our guest speakers from today. Now let's take a look at today's agenda. We will begin with a short introduction to the Copernicus Marine Service, followed by two presentations by Andrea Carvalho from Mercator Ocean. She will go over some Copernicus Marine ocean literacy resources and do a demonstration of a new ocean data viewer called MyOcean Health. After this, we will take a short coffee break for about 10 minutes. After the break, we'll continue with a live demo by Tony Jolibois from Mercator Ocean, who will introduce the MyOcean Lite and MyOcean Pro viewers. We will then wrap up the session with two presentations from users of Copernicus Marine data and tools, sharing how they integrate these resources into teaching the ocean. First, Stéphanie Lesage and Marin from Children for the Oceans will show how they raise awareness among children and the wider public about the crucial role the ocean plays for our planet. Then, Yanis Androulidakis, physical oceanographer and professor at the University of the Aegean, will explain how it integrates Copernicus Marine data into his teaching with a focus on extreme weather and ocean hazards. So let's start with a short introduction to the Copernicus Marine Service. Copernicus is the European Union's Earth observation program. Its core principle is simple but powerful, providing free, open, and reliable environmental data so that it can be reused well beyond the scientific community, including by professors and educators. Within Copernicus, the Copernicus Marine Service, which is implemented and operated by Mercator Ocean International, focuses on the ocean. It delivers high-quality, regularly updated data describing the physical ocean, sea ice, and marine ecosystems at global and regional scales. These data support science, policy, coastal management, innovation, and many different sectors of the blue economy. All Copernicus Marine data comes from a combination of three complementary sources: satellite observations, which provide global continuous coverage; in situ observations from buoys, floats, and research vessels, offering precise local measurements; and ocean models, which assimilate all observations and generate forecast, analysis, and up to 30 years of historical reanalysis. All this data covers the global ocean and Europe's key regional seas. The data is scientifically validated, consistent, and comparable across time and space, which makes it valuable for both scientific and operational applications. To make the ocean easier to explore, Copernicus Marine groups variables into three main families. The blue ocean covers physical processes such as temperature, salinity, currents, sea level, winds, and waves. The white ocean focuses on sea ice variables like concentration, thickness, and motion. And the green ocean includes biogeochemical indicators like chlorophyll, nutrients, oxygen, carbon, pH, and ecosystem-related variables. This means access to a very wide range of possible topics: climate change, marine heat waves, biodiversity, polar regions, extreme events, all from a single coherent data source. All Copernicus Marine data is accessible through a single website, marine.copernicus.eu. After a simple and free registration, you can browse the data store, download harmonized datasets, and explore detailed product pages that include metadata, documentation, quality information, and multiple data access options. From the homepage, click Ocean Products to open the catalog. In addition to downloading data, you can explore it visually using our online tools available under Ocean Visualization. There are three viewers, each designed for different needs. MyOcean Learn is ideal for outreach, education, and simplified exploration. MyOcean Lite, perfect for quick interactive viewing of essential ocean variables. And MyOcean Pro, our advanced viewer for more detailed exploration, selecting specific datasets, comparing satellite, in situ model data, performing custom queries, and generating high-resolution graphs. A little bit later today, Tony Jolibois from Mercator Ocean will do a demonstration of the main features of the MyOcean Lite and MyOcean Pro viewers. You're not expected to figure everything out on your own. There is a full support system for the Copernicus Marine service, tutorials, documentation, a help center, and direct access to the support team. Don't hesitate to explore the User Corner tab of the website to reach the help center, and a live chat is available at all times in the bottom right-hand corner. You can interact with Blue, the Copernicus Marine AI companion, which answers many questions instantly. And if the automated support is not enough, users can always reach a human expert for personalized help. Just as important, we actively collect feedback from users. It helps us understand how the service is used, what works, what doesn't, and how we can improve it, including for teaching uses. In the user corner, you can access the user feedback and needs platform, which is dedicated space for users to share ideas, suggestions, or needs. We also have an annual survey open until 15th of May, collecting feedback to improve the service and to which you can have access by scanning this QR code or clicking the link in the chat. So thank you in advance for your contribution. Last but not least, Mercator Ocean International and the Copernicus Marine Service have launched a new podcast called Decoding the Ocean. The series will explore how ocean science, digital innovation, and free and reliable ocean information have real-world impact. The podcast is available on all podcast platforms. You can access it by scanning the QR code on the screen or through the link in the chat. The first episode introduces the fundamental role the ocean plays in regulating the climate, supporting biodiversity, and sustaining human activities, while the second episode explores how ocean-based activities such as aquaculture and offshore energy form what is known as the blue economy. Thank you very much for your attention on this short introduction to the Copernicus Marine service. There are a lot of additional things to say and to present. And so I will give the floor now to Andrea Carvalho, who's the Science Communication Officer at Mercator Ocean, who will give us an overview of some of the many ocean literacy resources that are available from the service. So Andrea, are you here?
Hello. Yes, good
Hey.
morning. Hope you can hear me well
Yes, we
this
can hear
time.
you well. Yes, we can sit in presentation mode. So the floor is yours.
Perfect. Thank you. Thank you very much, Marin, for the introduction. And yes, so I will be going through a few of our ocean literacy resources. All of these you are able to find through the Copernicus Marine website. So we have a variety of resources and can be adapted to different audiences and to different level of expertise or even different age groups. So this is just an overview. I'll now go through each of them, just give you more detail on each of these resources. So first we have the ocean explainers. So these are the very basic information you can find in the Copernicus Marine website. These are informative pages with infographics that will explain from very basic topics, like, for example, what is an ocean wave, to more complex phenomena like ocean acidification or specific currents. So here you can find really the first level information on these topics, and also on what is operational oceanography, which is the core activity of the Copernicus Marine Service. So how is the data collected? Why do we need all these instruments, etc. And also on the different phenomena and threats that are impacting the ocean. So yeah, these are a very good start if you are maybe someone young who doesn't know much about the ocean yet, or a teacher who's looking to find basic materials to use in their courses. This is a good start. Another one is the Ocean Climate Portal. This is based on the information of ocean monitoring indicators. So these are key variables that are monitored throughout a long period of time, let's say at least 3 decades, and that provide us an information about the state of the ocean. So the Ocean Climate Portal is also a place where you can find a lot of information about these key indicators. What is the current state? What are the key trends of these indicators? So a lot of valuable information. So a little bit more advanced, maybe for someone who wants to know a little bit more in detail each of these variables and what is the state of the ocean related to these variables. So we already saw that we also have data visualization tools. Tony will show you a little bit more about these later. So we do have 3 levels of viewers: the Learn, the Light, and the Pro. I would say the very first level is the Learn, and so this is a very good first level to start playing with the globe, visualizing each of the variables, and also learning a little bit more about these variables, as each of these variables have an information, a little pop-up window with more information. This is a really nice tool also to, actually all the visualization tools are embedded and integrated in web pages. So you can actually use it in your own websites. And we have also used it, for example, MyOcean Learn, we have used it in a lot of exhibitions, in events, and we have also seen it exposed in museums. So they work really well, as they have this big globe and they're very immersive tools that work really well in places like museums as well. Okay, the next resource. It's the Ocean State Report, but more specifically, it's summary. So the Ocean State Report is an annual publication, the annual publication of the Copernicus Marine Service, that focuses on reporting on the state of the ocean. So the latest trends, the latest extreme events, and basically the latest knowledge about the state of the ocean. So this is a scientific publication. So every year we create also a summary of this scientific publication, which is focusing on non-scientific audiences, so mainly policymakers and the general public, but the level is supposed to be adapted to anyone that doesn't have a scientific background and just wants to know about the state of the ocean. So we normally adapt the language, of course. It has key numbers, a lot of illustrations to be easy to read, easy to scan, and to be able to just learn more about the state of the ocean. A new report that we have been developing since the last year is the Starfish Barometer. It's a yearly assessment of different topics related to the ocean, not only the state of the ocean, but also other topics like protection efforts, opportunities for humanity, societal harms, and human pressures, so all the activities that humans are creating that are impacting the ocean, marine ecosystems, and the different resources. So this is another assessment that we provide every year since last year. So a lot of key numbers, key information, and it is done in collaboration with a large scientific community, international scientific community. So this is like reliable information that is provided every year and freely, like all these resources that I presented. And lastly, we monitor the ocean continuously with the Copernicus Marine service, and we publish bulletins providing analysis on, for example, the temperature, sea ice, and marine heatwave events. So on a quarterly basis, we provide a recap, a synthesis of the last few months related to these different variables. So yeah, on our website, you can also find a section on the ocean health bulletins, providing this synthesis. So more knowledge, more information, and key numbers you can find over there. And that's it for me for this quick recap of all the resources you can find online.
Thank you very much, Andrea. Okay, so I will just share my screen again to actually talk about another resource that I think could be very useful. And then we will go to the Q&A section. Okay, so the final resources that I wanted to tell you about from this section was the e-learning material section of the website, which is designed to help users get started and go further in using marine data. So from the Copernicus Marine website homepage, you need to click on User Corner and then e-learning. This section brings together a range of hands-on tutorials covering different ocean topics and skill levels, from beginners to advanced users. All materials are freely accessible online. What makes this resource valuable is its practical approach, with many tutorials available as interactive Jupyter notebooks that guide users step by step, either online or locally on your computer. The tutorials also cover widely used tools and coding languages such as Python, R, and QGIS, helping users analyze and visualize Copernicus Marine data in real-world applications. We have more than 100 tutorials at the moment. So when you click on a tutorial, you're taken to a dedicated page with more details on its context and content. You will find links to download all the necessary files, along with a step-by-step video guide.
Hello everyone, welcome to this.
To help you follow the tutorial. You'll also see recommendations for the tools needed to run it. All these materials are completely free and can be especially useful for teaching in university settings, for example, to have students learn how to create graphs and maps using a range of tools encoding languages. So
Hello
don't hesitate
everyone.
to
Welcome to this
visit this section because it's very valuable, and we try to develop tutorials that are in line with current events that explore ocean phenomena. So have a look at this. Great. So now we will go to the Q&A session. So just a reminder before we go to it, you can access the place where you can ask your questions by scanning the QR code on the screen, or you can also click the link that is being shared in the chat. And this is where we will be collecting your questions. Keep this page because we'll get back to it every time we go to a Q&A during this session. And this is where we will collect all your questions. So let me see. Actually, we've started receiving some questions. So the first question is, we need to develop an app for fishermen, especially to provide them with potential fishing zones. My question is, if I take these datasets which have global coverage, how accurate is my information going to be at the local level, keeping in mind scale and coverage? I would say it really depends on the product that you actually look at and the resolution of said product. So this is an information you can find in each of the product pages and documentation, but not all the products have the same resolution. So yeah, I can't give a global answer to this question. It really depends on the product. The next question is, for the GIS tutorials, do you use S3 software or open source software like QGIS? We use QGIS. We make sure to use open source softwares and materials as much as possible. So yeah, you will for each GIS tutorial, you will find a PDF with all the steps to go through the tutorial, as well as the project that you can open in QGIS with all the necessary images. The data is also pre-downloaded in the folder with the QGIS project. And as I presented before, you also have the video tutorial that could be very useful to follow along as well. Next question is, do you have learning materials in other languages than English? That's a really good question. I think we have some in the e-learning materials section. But if you ask the user support through the AI agent, so Blue, which is on the bottom right corner of each page of the website, we might be able to provide you with some materials in other languages that are not available on the website. It's something that we are trying to work on, actually, to extend the number of languages that we work on. But they are mainly in English at the moment. Next question is, I am a senior environmental systems and society facilitator, and I found this resource very useful. Is there any possibility that you could conduct an online workshop with my students? At the moment, we are not planning for any personalized workshop, but that's something that could be discussed, I guess. So yeah, you can send us a message and see what's possible. The idea today is also to present the large diversity of resources that we have that could be useful for teaching, but obviously we're also very eager to get your feedback on what we're presenting today and what could be useful for you to go into more details because there are a lot of different things that we could be focusing on, and we could spend hours presenting tools. So yeah, don't hesitate to also fill out the survey after the webinar so that we also get this feedback from you. Okay, thank you. Next question is, can we use the software to create underwater maps like coral reef mapping, etc.? I'm not quite sure what software you're mentioning, but I think it's something you can do using Python. You could develop a tutorial doing this, I'm guessing, but I'm not quite sure what software you're referring to. I don't know. Andrea, do you have any idea what this question could be about? You're muted.
Tony wants to answer.
Yes, Tony, you have something you
Yeah,
want
what
to
I
say?
understand of this question is that the software is the services where Copernicus Marine are providing, no? And actually, that's my understanding. And to create underwater maps 3D, it's not possible for the moment. It will be in the future. But what I will show after is how to dig into the data in 3D and then 4 dimension using the graphs and maps and not directly 3D 3-dimension maps.
Okay, thank you. So yes, stay tuned for this presentation a little bit later today. Next question is about plastic pollution in the Mediterranean basin. So you won't be able to find data on marine litter and microplastic through the Copernicus Marine service. But you will find data about currents, for example, that could be useful in these types of uses. But yeah, we don't display data on marine litter, actually. I guess this is the last question that we will answer because we have to keep up with the timing. But the question is, what are the specific resources for educators? I think all of the ones that we've shared today could be useful for educators. I don't know, Andrea, if you want to add something to this.
No, that's it. Everything that I presented can be used in your classes for different. They can be adapted to different age groups, of course. But all of this can be a really good resource to be incorporated in your classes, either as an exploratory, more as an exploratory tool, do it yourself, or just a base information for students to learn more or to research about the information that is made available through the Copernicus Marine Service, being assessments or just these informative pages. All of these can be really good resources for you.
Yeah, absolutely. And you will also get inspiration from our 2 guest speakers a bit later today who are users of Copernicus Marine data and tools, who actually use the data either in university classes or in classes for students from primary school to high school, so who are younger as well. So I think these would be really good examples of how these resources can actually be used in the classroom. Okay, so thank you very much. We can now, I will actually stop sharing my screen and we can go back to you, Andrea, for the demonstration of the MyOcean Health viewer, which is a very valuable tool that is going to be available very soon. So the floor is yours.
Thank you. Yes, so a little disclaimer. This tool is not yet available, is in beta version, and we will be launching it officially next month, so beginning of June. And yeah, we're very happy to make it available. We know that it's going to be very useful, and yeah, we're very happy with it so far. My colleague Tony was heavily involved in this, and yeah, we're very happy to make it available soon to you. So it's MyOcean Health. It's a new interactive tool, and it's focusing on showing key ocean variables such as sea surface temperature, which is what you're seeing here, and others such as marine heat waves, sea level, pH, which is a representation of ocean acidification, and Arctic sea ice extent, for example. And so MyOcean Health, because these variables, when they are measured over a long period of time, they can give us an idea of the health of the ocean. And so the tool focuses on providing a vision on a globe. So you can see, for example, here we see sea surface temperature. It's represented in this colored scale, and we see the typical difference in temperature, right? Warmer in the tropics, warmer in the closer to the equator, colder near the poles. So you can actually really rotate the globe, so quite interactive. And here we are seeing the sea surface temperature for the global ocean for today. So we will display daily values, daily data, so on real time, and also all the way from since 1993. So here you can choose another date, the sea surface temperature at another moment in time. And on the right-hand side, we have a graph, what we call a time series. So a graph that represents sea surface temperature since 1993, all the way to today, 2026. Here we are, and we have sea surface temperature, the average sea surface temperature on the global ocean for today, 21 degrees. You can also see these values on a monthly and annual basis. On an annual basis, you really get the idea of how this has been changing since 1993, and we see it is globally increasing. So besides the absolute values, we also have anomalies. So an anomaly, for example, related to sea surface temperature is a temperature value that is above or below a certain average. So an average that has been measured for at least 30 years, for example, and we know that that's the average temperature for this particular place. And an anomaly is when this temperature is either above or below. And so here you can actually see on the globe the areas in red where temperatures were above this average, and the areas in blue where the temperature was below this average. So this is for January, but you can also see it for today, like we saw. The same for the time series. So this is quite interactive. You can pick another year, for example. You can select, quickly check the temperature for today and compare it to another year. So it's really useful to see ocean change through the different variables. Another variable we show is marine heat waves. So we hear more and more about marine heat waves, unfortunately. They are becoming more intense, more frequent, and very present around the global ocean. The marine heat waves are extreme events events of extreme temperature that last for at least 5 days. That's when we consider a marine heat wave, when it has been an extreme temperature has been present for at least 5 days. But they can last many, many days, 2 months and up to 2 years even. And so when these events are intense and last for a long time, this can be quite impactful on marine species. And so, we know, for example, coral reefs are quite sensitive to temperature, but also different species of fish that can be quite stressed about these changes in temperature. So this is something else we also show in MyOcean Health, and actually we also include a forecast, so you can see what are the conditions in marine heat waves going to be for the 9th of May, for example, already. So we show a 10-day forecast for these conditions, the same for sea surface temperature. Another variable, which is also quite interesting to look at, is sea ice extent. So sea ice is the seawater that has frozen. I'm going very basic here on the concepts because I don't know who the public is, who the audience is. So we're talking about the seawater that has frozen, and so sea ice extent is the area occupied by the sea ice. And so we measure that daily as well. The Copernicus Marine Service, we look at these values on a daily basis and on a monthly basis. And so here on our graph on the right-hand side, you can see for sea ice in the Arctic, which is what we are seeing here, there's a clear pattern that is repeated every year, right? Because it's a seasonal cycle that we see. There's increase in sea ice that reaches its peak during the winter, normally around February, March. And then it starts to decrease, melts, until reaches a minimum around the end of the summer on the northern hemisphere. And so, yeah, we see this pattern being repeated every year. So we also can see very clearly, if we look at this dashed line, it represents the long-term average of sea ice extent in the Arctic for each day. And we see that the 2026, or where we are now, is well below this average. We are here, 2026, and the average is here. So it's quite obvious the change that has been happening over the years. And yes, so it's a very visual tool and also quite interactive. And another very useful feature of this new tool is that you can download an image of both the globe and the graph. So you can use to illustrate whatever you would like, an article or a web page, but you can also integrate these two materials individually on a web page as well. So let's say you're creating your own ocean literacy resources, you're creating a new page dedicated to sea ice, and you would like to have something like this in your web page, you will be able to integrate these features and be able to have it also in an interactive mode. So yeah, I think I gave you more or less an overview of this new tool. So yeah, like I said, it's not yet available, but it will be very soon, and you will know more about it, of course, if you follow us on social media, and yeah, if you follow it on our channels, you will know when this will be out. Yeah. Okay, that's it for this short demonstration.
Thank you, Andrea. I think it's a very valuable tool, and I can imagine a lot of different uses for it as well. We received some questions, so I will show them on the screen. The first one is a very good one, so if you could give us a little course on marine heat waves, it would be really appreciated. So the question is, why are marine heat waves increasing?
Well, we know that the ocean is warming due to greenhouse gas emissions. So the Earth is warming, and the ocean is taking up most of that heat that is being trapped in the atmosphere. So most of it, so close to 90%. And so all this heat that is being trapped in the ocean is causing a lot of extreme events, including marine heat waves, for example. This is one of the reasons that we know. at least.
Okay, thank you. The next question is, how do the tools define the baseline for a heat wave?
So I do know that it is a statistical calculation that is done. It's a method that is already extensively accepted in scientific community, and it wasn't something that we invented. We took that method and we applied it. So yeah, I hope I answered your question. And then as a long term, or I mean baseline, if we're talking about the sea surface temperature baseline that we use, that would be a period since 1993 to 2022. That's our sea surface temperature baseline.
I think the ocean health bulletins that you presented earlier as well, there are some focusing on marine heat waves that could be quite useful also to answer any question related to this.
Yes, so we monitor marine heat waves on a monthly basis, but we also produce a weekly forecast on marine heat wave events. Yeah, we can definitely share the link with you guys. And this is something, if it interests you to know more about how this has been evolving, definitely.
Next question is, do you use NOAA data for SST, or where does your data come from?
I know that it's our model data, so it's from our global ocean model produced by the Copernicus Marine service. We do use observations that we use to validate our models. And I do know that they come from different centers. I wouldn't be able to answer if it is NOAA, but we do use observations from other centers, which are used to validate our sea surface temperature models. Yes.
Great, thank you. Next question is, what does this biomass refer to?
Biomass? I don't think I showed it in biomass. On the MyOcean Hub, we don't have at the moment any biomass. We do show chlorophyll but I think Tony can talk a bit more about that later on, because that's visible in we do have products that include biomass, but it's, for example, for chlorophyll A, something like that. I didn't show any biomass here.
Okay. How accurate is the data for the marine heat wave in Antarctic, where we have very limited data?
Well, I'm not the one working directly with the data here, so I wouldn't be able to answer you in this sense. If you have any specific questions, I think you can contact us. I mean, if you work on the topic or something like that.
Absolutely.
We're happy to help you.
This is also an answer we could integrate into the post-event report that we will be sending with unanswered questions from today. So go back and check this report for more answers if we haven't had time to actually answer your question during the event. The next question is, I am a math teacher in high school. Which tool do you suggest to use in a classroom in order to introduce ocean analysis and environmental knowledge for young people?
So definitely the viewers are a very good option to visualize, I guess, the way the different variables change across the globe. And you can also have access to the different values in different areas of the globe. The Ocean Climate Portal also provides some knowledge related to key variables and how they have changed over time. And soon MyOcean Health, of course, that will be a very good tool also to show these changes. Yeah, from the top of my head, I'm just thinking about those.
Yeah, I think the MyOcean Light viewer focuses on some key variables that are quite interesting to look at in terms of ocean variables. So I guess that's definitely a tool that Tony is going to show a bit later today, and I think it's very visual to be
exactly.
able to understand what's happening.
If we focus only on a tool, of course, because then there's other resources that can be they have environmental knowledge, but it's not necessarily a tool. So
yeah. And I guess also the ocean explainers are really good resources to understand ocean phenomena as well.
Exactly. Yeah, if you call everything a tool in this sense, we have our own wording, but definitely, I mean, everything that we have shown before, these are all very good tools for environmental knowledge, different levels, like I said, and more or less interactive, more or less visual.
Next question is, as not being an ocean expert, I have difficulties interpreting the data observed. So my question is, how can you interpret the listed events as hazards? Would it be possible to refer next to the graph some thresholds impact on marine life?
Yeah, I see. We do provide some key numbers together with the graphs where we explain, okay, how much has for example, how much of the globe has been impacted by this phenomenon last year or something like that. That is something that it was already thought. And yes, we don't provide necessarily, once the tool is visualization tool, we don't provide necessarily the, let's say, the context directly with it. We do have other resources, like we have our bulletins that are more thorough explanation on, for example, the analysis of what happened last year. But it's true that we could try to maybe connect it more or bring more context to the visualization tools to give more context, right, on what people are observing.
Yeah, that's a very good suggestion. User feedback, perfect.
Yeah, exactly. We're always interested to learn more about how our tools can be useful, more useful, and adapt to other contexts, definitely.
Definitely. Next question is, I think this one is a very wide one. So could you please explain how Copernicus collects the data? So I don't know, Andrea, if you want to give it a try.
Well, you did say it in your presentation, right? Like we use in situ observations. So instruments like buoys, like moorings and gliders. So these are instruments that we deploy, are deployed everywhere in the ocean. They are collecting data in a specific location, right? This is a vast network of instruments. And then we also have the Sentinel family of satellites. They are part of the European Commission, and they are collecting data on different levels of the Earth, including the ocean. And then, so this is for the collection of data itself. And then we also have the development of ocean models. So mathematical equations that can recreate the ocean conditions for the areas, for example, where we don't have data. And so, it's very generally.
Yeah, there's a lot of different ways that data is collected, and a long process of things happening before the data actually lands on the website and is available for users.
We actually have an explainer on that as well.
Perfect. Here you go, Ocean Explainer once again. Do you have mapping system for blue carbon stocks in coastal areas and in ocean?
I don't think so. To measure carbon, of course, in the carbon flux, but not, if I understand, is like regions where carbon is being really absorbed by marine species, right? Like seagrass or something like that. This is not something we have, not at the moment.
No, but if you want to browse through the products offering carbon as a variable, you can also ask the AI agent Blue for to be pointed towards one of those products that offer this variable. If you want to have a look in the viewer, for example, for this kind of product, or to download the data, this is a good question to ask the user support team and the AI agent. Okay, we're going to take a few more questions before the break. So the question is, do your models help predict El Niño and La Niña, or only show past data?
We don't show only past data. We also create forecasts up to 10 days. And there's also work being done on creating forecasts a little bit longer, up to 30 days. But we are not able to create yet seasonal forecasts, or like at least we're not distributing yet forecasts that are like months in advance or something like that. So if we are looking at, for example, El Niño or La Niña in few months in advance, we wouldn't be able to see that. But yeah, it depends. If we are looking into the next 10 days, we would be able to tell you a bit more about the conditions in the ocean. Yeah.
And actually, Tony Jolibois a bit later will show a dashboard that was created focusing on El Niño. So stay tuned for this, because I think it's also a very valuable tool to have a look. And in the dashboard, we can actually see the evolution that's happening at the moment. So yeah, definitely stay after the break to see this as well. Do you have any resources specifically covering kelp? We have a unit on the degradation of seaweed forest and what can be done to mitigate this. Perhaps there's some information on kelp ecosystem coverage over the decades.
I don't think we have on that. I know that there are others. There's new products being added related to marine ecosystems, but they include mainly zooplankton and lower and higher tropical levels, certain species of fish, but they don't, as far as I know, I don't think there's anything related to kelp. No, we do distribute all the data and information related to physical components of the ocean that can probably help in your study. So information related to the sea surface temperature, related to biogeochemistry, so the content of chlorophyll, oxygen, and carbon in the water, currents, yeah, all physics, and some biogeochemical conditions that can help you maybe in your study.
Perfect. Thank you. Next question is, can MyOcean Health provide data filtered by region or area of interest? This capability would be beneficial for regional studies.
Yeah, so in the current version, this feature doesn't exist yet, the regional selection, but it is something that we are working on adding in the future, definitely. The regional, the different regions of the globe, different ocean basins are definitely an interest. And we know that it is very interesting to focus on each basin. So it's definitely something we are working on adding in the future.
Great. We will take one last question to keep up with the time. So
many questions. That's good.
yeah, we are receiving actually a lot of questions. So we'll definitely be sending a post-event report to address all of these. I am conducting a study on the impact of ENSO on ocean currents and sea surface temperature in Indonesian waters. How reliable is the reanalysis data from Copernicus Marine Service for regional scale studies like this? And what limitations should I be aware of accuracy and application?
Yeah, so I think it's not so much a question for me, since I don't work directly with the data. So I think this question should be best sent to the user support And yeah, I think it could be something that they can help you with that. Yeah, that's all I can say.
Uh, yeah, definitely. A question. I guess once again, maybe ask the question related directly to the product that you would like to work with. The data is validated. It follows a very rigorous scientific process, so the data is obviously reliable, and this is information that you can find on documents that are available from each product page. That actually give a lot of details about the data, how it was collected, how it's validated. All these processes is described in these documents, and I think if you want to have all the details about this, you can definitely read through these documents that are available from the product page on the left-hand side of the page. So definitely have a look through these. And I just see the next question is, are the tools free to use for research and educational purposes? Absolutely. Everything is free to use. The data is free to download. You just need to create an account on the Copernicus Marine service to access some elements. For example, if you want to download the data, you will have to create an account. But you can also just view some of these tools without having to create the account. But yeah, everything is absolutely free. So thank you very much, Andrea, for your presentations.
Thank you.
It was really great. We received a lot of questions. We will now take a short break of about 10 minutes. So we'll be back at 11:10 Central European time. And we will have a presentation and a demonstration of the viewers we've been talking about since the beginning. So yeah, see you in about 10 minutes. Hello again, everyone. Hope you had time to grab a coffee or some snacks. I can see that Tony is here, so we'll restart the session with a demonstration of the MyOcean viewers by Tony Jolibois from Mercator Ocean. And I think, Tony, you will also say a few words about the MyOcean dashboard as well. So the floor is yours whenever you're ready.
Yeah, thank you, Marin. Hello to all. So I'm Tony Jolibois. I'm delighted that so many of you are here. So to access the viewer, just reach the Copernicus Marine website, click on visualization tool, and you have here the three viewers that Marin present you just before. And I'll present you the MyOcean Lite and the MyOcean Pro, and maybe MyOcean dashboard if I have time, but I won't go into all the features of these tools. It would require much more than 25 minutes. So I'll focus on some stories, but possibilities are really endless. Using these tools, you can illustrate with maps and graphs a lot of stories and studies for your students. So first, MyOcean Lights. This tool, so you see there is for new user a tour that is proposed. So this tool allows you to display about 10 essential variables of the ocean, of the blue, white, and green ocean from nearly 1993 to forecast. So you are here looking at the seawater temperature for the 6th of May. It means tomorrow. And you can navigate on time using this timeline. And you can also navigate on depth using this control here. So I reach again the surface. So this tool is interesting for beginners and intermediate users. Everyone who wants to look at the ocean without having to choose among products. If you want to display temperature, you just click on temperature. If you want to display salinity or so on, just click on the variable control here. So MyOcean Lite will always display the best data available. For example, here we are on global scale and we are in the past, March 2025, and behind the scene, the MyOcean Lite select the global product and the multi-year product, which is with the best quality than the near real-time product. If I zoom on the Mediterranean Sea here, the tool just switched to the Mediterranean Sea product. So yeah, just the best data available automatically selected for you. What is striking about these viewers is that they provide interactive access to the data in real time. So looking at each variable at global scale, you can examine the geographical distribution of the values. So for temperature, of course, warmer near the equator and cooler near the poles. The salinity, you can see the river, the inflows from rivers like Amazon, Congos, and so on. The current. Oh, let me customize a bit the color palette. I prefer that one for the current. So for the current, you see with the color, the intensity of the seawater velocity, and with the streamlines, you see the direction. So here, clearly for beginners, we see the ocean gyres clockwise in the north hemisphere and anti-clockwise in the southern hemisphere. Yeah, thank you. You can also see all the famous current of the ocean, the Gulf Stream here, the famous current in South Africa here, the Algolas current, and so on. The sea surface height, so no, the ocean is not flat, and the sea level rise is not uniform. Wave height also. So again, the direction and intensity here. So you see a lot of variable. Also the biomass. There was a question regarding the chemistry of the ocean. So we have chlorophyll A for the phytoplankton, the pH, the oxygen, and the biomass. Okay. Okay. Let's start with a simple question for a beginner. Many people believe that temperature mainly depends on latitude. The closer you are to the equator, the warmer it is. So let's check with using real ocean data. So for that, I will create, just by clicking on the map, different points on the same latitude near Marseille, near Biarritz, near north of Portugal, and near Canada. Okay, it creates, sorry, it creates some graphs that I can group here very easily. Okay, so I maximize it. I just remove the graph I don't want to talk to speak about, sorry. So yeah, we see here that, of course, different points on the same latitude have different seawater temperature. It's quite different. 4 degrees near the Gulf of Maine, and something quite harmonized here, but that is not always harmonized. For example, here you can see that in Portugal, the seawater temperature is really cooler than in the Mediterranean Sea. So here, sorry, I forgot to say this is but it's quite obvious, no? This is the time series of the different variable at the different location of the point. So A, B, C, D, E, and you can navigate on time using the graph. So to reach the minimum, for example, here, the minimum in 2025, or the maximum, you can zoom on graph using the mouse wheel, okay? And each time you navigate on time here in the graph, you have the date here in the timeline. You can also navigate with the timeline. Everything will be updated accordingly. So as you can see, this MyOcean Lite is quite easy to use and quite relevant for intermediate and beginners and intermediate users. So if you want to go further, you can switch to the MyOcean Pro viewer. So from here, you click on the Go to Expert viewer here. So no main differences in the switch, except that you have statistics here. You can see here the average on time and the minimum and maximum. I don't know if you see it quite clearly in the screen, in the shared screen. The numbers are quite small. So a big difference with MyOcean Lite is that when you want to navigate in the data, you click here on Add Layer, and you reach all the Copernicus Marine products, meaning more than 300 products. So can be quite difficult to find your way around. So you can use here some filters to find your way around by selecting the data by universe, blue, white, green, by the main variable, by areas, and you also see here the source of the data. So all the Copernicus Marine data come from numerical models and observation, in situ observation and satellite observation. So an example on how the tool can be used to teach the ocean, the bloom of phytoplankton in the North Atlantic Ocean. So to do that, I can select plankton, and here I reach the model output, the biogeochemistry analysis and forecast. and I can add to map the phytoplankton daily. Okay. Can delete these graphs and let's focus on phytoplankton. So we can navigate on time and just again with the timeline, you can zoom with the mouse wheel. So here, okay, we are the beginning of March, and if I navigate toward the spring, you can see the rise, the bloom of phytoplankton here. So what can be cool is to generate temporal animation on that. So to do that, there is this share button where you can copy a link to share with people. So this share button allows you to share what you are your use of this tool. So you can share a link to people. You can share and export an image, or you can generate a temporal animation. To do that, you will need an account. So here I'm logging in, and then I can generate a temporal animation of the phytoplankton, the chlorophyll A, between maybe beginning of March until now, no, until even the forecast, and generate video. So I just to avoid wasting time, I have generated the temporal animation just before this presentation. So we see here April, end of April, beginning of May. And yeah, this is clearly the spring has arrived in the North Atlantic Ocean, and every year between April and June, the annual peak of phytoplankton can be seen here. Okay, so something I wanted to show you also is how to, if you want your student to manipulate the data directly, you can download the data. Here again, you must be logged in, and again the registration is of course free. There is no money here. The goal of the registration is just for us to know the usage of the services and the data. So to download the data after login, you click on this button, and if you want to focus on that part of the ocean, you define here and you click on download, and then you download a netcdf file. So I won't go into the detail of all of this. Okay, so what's I can't remember when I should stop. Maybe this is okay. So I wanted to show you also the monitoring of El Niño, and for that we have oh yeah, there was a question on the concentration of microplastic in the Mediterranean Sea. For that, you can reach the Necton viewer. So Necton is another project related to the Copernicus Marine service, and there is the same MyOcean Pro viewer, and you can browse the catalog of Necton to see to look at the microplastic in seawater. But coming back to El Niño southern oscillation, so there are some this other tools, so MyOcean Lite, MyOcean Pro, and then this dashboard allows you to have a dedicated page focused on a region and on a topic. And you can play with maps and graphs and so on. You can move it as you want, and you can annotate all the maps and graphs you have just created. So here, this is a map of temperature anomaly in the Pacific, equatorial Pacific Ocean, and I've imported the different Niño boxes that are standard in the scientific world to monitor El Niño. So here, the graph presents the time series of the temperature anomaly averaged on each box. Okay, so you have here in blue the Niño 1+2, the Niño 3, Niño 3, 4, and Niño 4. So it's very easy with that kind of graph to see El Niño event or La Niña or a neutral situation. And again, you can always navigate in time using graphs. So El Niño is declared when the average temperature stays more than 0.5 degrees above the long-term average for 5 consecutive months. So here we can see easily the beginning of El Niño in 2023. It began in April and nearly 1 year later in March 2024. So again, here this tool is quite powerful as it gives you some statistics on each El Niño box with the average, minimum, and maximum of the temperature anomaly. So coming back to the real time, here we are in May, so the 5th of May, okay, and here by the end of April, you can see that, okay, forecast is here. I'll just click on the plus here to extend the time frame. So it computes average on the several boxes. So it takes time. And you see here the rise of the temperature anomaly. As Andrea said, and to answer a question just before, we don't generate climate prediction or seasonal prediction, but we generate 10 days forecast of data. And we can see here that maybe El Niño is starting with temperature above the anomaly. Okay, I think I'm okay. I'm okay for that demo.
Okay,
Yeah.
thank you, Tony.
Marin?
Thank you very much. We actually have some questions for you. I just wanted to mention before that we have replays of previous sessions available. For example, a session focusing on the MyOcean Pro viewer, which was a 2-hour session showing all the different features of the viewers, how to download data, etc., in more detail than we have time for today. So we will be sharing the link to this session in the chat so that you can have a look at it if you're interested in diving deeper into this tool. And we also have a similar session for the dashboards that Tony just showed you, which shows how to create your own dashboard if you're interested in monitoring a certain area, for example. So we will be sharing the links to these replays in the chat, and they are very valuable resources, so don't hesitate to have a look. And now for the questions. So the first question is, what does biomass mean in datasets?
Yeah. The general question, but biomass is the total mass of living organism in the seawater. So it includes many organisms living in the ocean. I mean, we could spend 2 hours answering this question, but yeah, biomass is the first the first step of the food chain of the earth. Mm.
Yeah, it could be phytoplankton biomass or zooplankton biomass, for example.
Yeah.
So yeah, it can mean several things. It can mean we're looking at several different things. Thank you. Next question is, how can I use Copernicus Marine data for fisheries management in small island countries like Comoros? What are the best data sets for identifying potential fishing zones? I would say that this is also a question that you can ask Blue, the AI agent. He's very knowledgeable about the products, and he can definitely help you pick out which products could be useful for such applications. So really don't hesitate to use this tool because it's very helpful. And if you're not satisfied with the answer, you can ask to speak to a member of the user support team who could actually help you answering this question. I don't know if, Tony, you wanted to add anything to this question?
Well, I mean, identifying fishing zones typically relies on a combination of physical, biogeochemical data, such as sea surface temperature, chlorophyll concentration, ocean currents and fronts. So yeah, again, it's quite wide question. But just regarding the small island countries, so our data sets have a good resolution, but not so high to work on very small areas. So yeah. mm, have to see, and it's a good advice, yes, Marin, to ask Blue and the user support for that kind of question.
Okay, thank you. Next question, please. Is can I use this tool to generate coastal early warning system? So I guess the answer would be a bit similar to what we just answered before, really depending on on what you're trying to do. I mean, the tool can be useful as well, but maybe the data is useful, and the fact that you can download the data as well, I think, is a good thing to keep in mind for this if you need to incorporate the data in another application that you're developing, for example. This is possible. Next question. How can beginners start using NetCDF data in QGIS? Are there free training programs or certifications available? Do you provide step-by-step tutorials for beginners? Is there support for users in Africa or small island developing states? So we definitely have tutorials on QGIS. There is a plugin that was developed a few years ago to open NetCDF data into QGIS. The plugin is called NetCDF to QGIS. So you can download it directly from the Copernicus Marine service website. Once again, you can ask Blue and it will be able to direct you towards the plugin to download. And if you go through the e-learning materials section on the website, you will find some QGIS tutorials. We're always open to learn about your specific needs in terms of topics, etc., for tutorials to develop. So don't hesitate to let us know as well in the survey if there is any topic in particular that you'd like to see in these tutorials. Is this setup also used for freshwater water body system?
If the freshwater water body system refers to land data, no. We, as the Copernicus Marine service, focus on the ocean and seas. We don't provide data on the land part. There is the land Copernicus, the Copernicus Land Service that is providing that kind of data. Otherwise, we provide fresh water for the ocean and seas, as I just mentioned before, with using essentially the seawater salinity. And again, we clearly see the river inflows in the ocean. Yeah.
Okay, thank you. And we will take one last question, which is the question about the API. Is there an API to access and use the data in other application environments, such as Google Earth Engine or Python?
There is an API, I mean, a tool to access, to download the data in Python, which is the Copernicus Marine Toolbox. You can use it in command line or directly in Python code to select your data and download the data on the area of interest and also the temporal coverage and so on. There are a lot of documentation on this tool, so you should search for Copernicus Marine Toolbox.
Yes, I just shared the link in the chat to an introduction about the toolbox if you want to have a look at this very useful tool. So sorry, we don't have any more time to answer questions. We'll answer these in the post-event report. Thank you very much, Tony, for your presentation and demonstration and answering all these questions. We will now go to our next speakers.
Bye-bye.
Thank you very much. who are Stephanie, Lesage, and Marin from Children for the Oceans. They will be telling us a little bit more about how Children for the Oceans uses Copernicus Marine and Mercator Ocean data and tools to raise students' awareness about ocean protection. So the floor is yours whenever you're ready.
Okay, thank you very much, Marina. And maybe I will ask Marin to share the presentation.
Yes, of course. Can you all see me?
We can't
Yes.
see you. Oh,
Oh.
yeah, we can now. Yeah,
Okay.
all good.
Okay, so I'm gonna share the presentation right now.
Yeah, perfect.
Up. So
Okay,
can you all
thank
see
you very much.
right now?
Yes.
Okay,
good.
so good morning, everybody, and thank you very much for welcoming us today. We are very pleased to present Children for the Ocean, our work with young people, and more specifically, how we use scientific tools developed by Mercator Ocean International and Copernicus Marine Services in our awareness session. Next slide, please. So Children for the Ocean is an NGO dedicated to ocean education and youth engagement. Today, our objective is not only to present what we do, but also to show you how scientific data can become powerful tools when it is made visual, accessible, and inspiring for students. So about our NGO, Children for the Ocean was founded in 2018 after a sailing expedition around the Atlantic led by our founder, Thomas. And this journey was the starting point of a simple conviction. If we want to protect the ocean, we first need to help young people understand it, feel it, and connect it, and realize that their daily actions matter. So our mission is built around three main pillars, objectives. First, we raise awareness among children and teenagers about ocean protection. Second, we train a community of young ambassadors, giving them the scientific context and pedagogical tool they need to speak to other people. And third, we represent youth voices in major international ocean events, so that young people are not only learners, but also are very active participants in ocean protection. Next slide, please. Yeah, some key figures. So since its creation, Children for the Ocean has reached more than 3,000 students, reached in more than 10 countries. We have now a community of 25 ambassadors across Europe, the Americas, and Asia. These numbers are important because they show that our model can travel and young people can speak to young people in schools, events, and local communities using a common scientific and educational framework. We have also developed several of what we call flagship projects, for example, Coral Reef for Children, which helps students understand the role of coral reef and the threats they face. We have also created an interactive workshop on marine protected areas where students take the role of different stakeholders and debates protection measures. More recently, we have developed a project called Children for the Mediterranean Sea, and we also participate to major ocean events such as United Nations Ocean Conference in Nice in 2025. Next slide, please. So our impact is based on two main ideas. The first one is peer-to-peer education, young people speaking to young people. This creates a very different atmosphere from a traditional classroom lecture. Students often feel more comfortable asking questions, reacting, and sharing their own ideas. But this youth-to-youth format is supported by solid scientific content especially through our partnership with organizations such as Mercator Ocean International and the Blue World Institute. The second idea is inspiration. We do not only want students to learn facts about the ocean, we want them to become curious, to care, and to feel that they can act. For many students, the ocean remains distant and abstract, especially when they do not live near the coast. So our role is really to make the ocean visible, understandable, and emotionally meaningful. So I let the floor to Marin for the rest of the presentation. Thank you.
Yeah, of course. So thank you, Stephanie. So first of all, before moving on to our approach, how do we approach these awareness sessions? I'm going to present myself. So my name is Marin. I'm a Children for the Ocean ambassador based in The Hague and currently doing my studies in Leiden University College. And so our approach is simple. It's understand, alert, and act. So we first need to ask, why do we need the ocean to understand? So this allows us to explain how deeply human societies depend on the ocean, notably for climate regulation, for oxygen production, as 50% of the oxygen comes directly from the ocean, food, transport, biodiversity, and also livelihoods. But then we ask, and this is the alert part, what threats does the ocean face? And so here we introduce major issues, not all of them evidently, such as acidification, overfishing, plastic pollution, climate change, and ecosystem degradation. And this is key. And finally, we asked, what can we do at our level? And this last part is pretty essential in our awareness sessions. It's the part basically where we want students to leave a session not only with concern, but also with ideas. For example, reducing plastic use, changing consumption habits. And one of the most important parts is sharing what they learned. So from word to mouth to the parents and to their friends, sharing basically what they learned, the curiosity it provoked, and understanding that small actions can contribute to a wider collective effort. And this is key. And so here we arrive to really, I would say, the heart of the presentation. So the question is, what Mercator Ocean International and Copernicus Marine Services make possible? Well, I would answer simply that the tools are extremely valuable to us because they help transform a complex ocean science into something students can actually see. And so what are we talking about right now? We're talking about ocean currents. We're talking about chlorophyll concentration, sea ice, temperature, or plastic dispersion. And these factors can be difficult to explain with words alone. But when students really see this phenomena on a map through animation or visual layers, the ocean then becomes much more concrete. And so for a classroom, this changes everything. Students no longer only learn about the ocean as being a distant, let's say, mass, which represents 70% of our globe, but it becomes real. They observe the ocean, and so the object becomes data, becomes a map. The map raises questions, and those questions lead to actions. And this is exactly what we try to do at Children for the Ocean, is basically to turn scientific information into a visual, accessible, and motivating educational experience. And so now I'm going to pretty much illustrate how we make possible the Copernicus Mind Services, how we visualize them and how we present them through our sessions. First of all, we get questions from when we go to primary schools about the ocean current, about the Gulf Stream. What is it? Well, we simply show this animation finished by Mercator Ocean Copernicus Marine Services, which shows in red the hot currents, and in blue the cold currents located beneath the water. And here, this animation is actually key, is not only showing the world currents, it's key to show that, first of all, there are no real borders within the ocean, and what happens in one region actually can have consequences elsewhere, because water masses, heat, nutrients, animals, and pollution move across the planet. And we have notably a second animation with the MyOcean Learn platform, showing us, helping students understand why basically this ocean protection needs to be treated as internationally, as as a global issue, and not notably not only reserved to one country. But then we have other tools such as the chlorophyll index, so understanding life in the ocean. So this is one of the best way to help students understand where life begins in the ocean, because we can see the concentration of chlorophyll in a certain region, and also to help understand that fishing does not only happen at the middle of the Atlantic Ocean, for example. It often happens near the coast, and also near marine protected areas. And so it means that protecting fish stocks is not only about limiting fishing, but it is about how to protect habitats, food webs, and the ecological conditions that allow marine life to recover and thrive. But then we have other tools which we show. This one I love, because students often ask us, what is the seventh continent on Earth? What does it mean? I don't understand. Apparently, there's a plastic continent in Northern Pacific, and so here with this animation, we can really show how, for example, dropping a plastic bottle in Toulouse when it takes the Garonne, and when it ends up in the Gulf of Gascogne, how does it end up in the middle of the Atlantic? And so I think this animation is key, with notably the timeline, with the months and the year, to show how the idea of plastic continents can be misunderstood. It's also, it comes from everywhere, and it's with the global ocean currents that it forms sort of gyres, which we call in France, but these plastic continents. And this helps students understand that plastic pollution is not a local problem only. It's actually a global issue shaped by human behavior, by waste management, and by ocean circulation. But then we also love to show this animation. So this one is presented by the new tool Edito, from Mercator Ocean, which they are developing, and we're looking forward notably to working with these tools. But this, I think, is really essential, because in our awareness sessions, we tend to ask the students, where do you think the most plastic, where do you think the majority of the plastic from the ocean comes from? And here it is actually we know that it is from the coast, with notably a pinpoint of Italy. But we also learned that it is 20% of plastic comes from the rivers. And so when we say that, oh my God, I live 200 kilometers from the ocean, I have no I have no impact on the ocean. Well, in fact, you do, because with rivers, with water points, it is all connected. And here we learned that, for example, 879 tons of plastic in 2018, from April 1st to May 1st, comes came from rivers. And so this is really essential, with understanding where the plastic comes from, and how it is not only beach pollution, but it is city pollution. So this is key to understand, and I think we are done here with the time. And I would like to thank you all, and we're open for questions. Thank you.
Great. Thank you very much for this wonderful presentation. We received a few questions for you, so I will start sharing my screen.
Okay.
Okay, I think we received the same question a few times. So the first one is, how can I sign my school up?
The best way is to write an email to Children for the Ocean, and just letting us know your interest and your willingness to organize an awareness session in your school. And then after, depending on schedule constraint, and we try to do our best to organize such a session.
Okay, and we shared the link to the website in the chat. If you want to also send us the email address you just mentioned.
Yeah, I will send it in the discussion in the chat.
Perfect. Thank you very much. The next question is, how can my students become ambassadors for Children for the Oceans?
Sorry.
Yeah,
please go ahead.
I can answer. So it's really simple. It can pass by many contact points. We usually get contacts from Instagram. Also, we have an Instagram account following what we do. But I think the easiest option is on our website. I think there's a link in the chat. There's a join us button, and you can basically write an email, and we provide the training and regular calls to organize sessions, and yeah.
Great, thank you. Next question is, how do we register for the interactive workshop? If it's possible, could you please kindly provide... Oh, can you put the question back, please? But the question is, how do we sign up for the workshops you mentioned during the presentation?
Oh, okay. So regarding the marine protected areas, so it's the same than awareness session, meaning we need to schedule them. For marine protected areas, we need more ambassadors because it takes longer. It's a session of generally 2.5 hours, and it's dedicated to I would say teenagers and not students from primary school. It's because you have definitely it's an interactive game, so they have really to play a role, and so it's much more active and require much more involvement from the students. So that's why we recommend doing such a interactive game for, I would say, students of 15, 16, 17 years old.
Okay, thank you. Next question is, does Children for the Ocean do training for other students? I feel like you've answered this question already, but I don't know if there's anything that you'd like to add.
That's really the key principle and key concept of the Children for the Ocean, meaning it's youth, speaking to youth. So that's why a large part of our work is really to coach and to train these students, these young people, to be to help them be ready to deliver such awareness sessions.
Okay. How do you overcome climate change anxiety amongst children? I guess this is quite a big question.
Yeah, it's a big question. Maybe I can answer this because I feel a bit concerned. As I'm not gonna lie, I had big periods where I had big doubts about and I constantly have doubts about the future, about climate change, and very often anxiety, what you call anxiety. But I think that the most let's say viable and action is to actually act upon it, to actually feel like you're adding your grain to the monumental action and how can I say this, to the greater good, but I think it's really hard, but I think the most viable solution is to act. And this is why I'm now involved in Children for the Ocean, is because during these awareness sessions in front of the youth, I feel this kind of hope amongst the children, and about this sort of general awareness of the issue, making it better for the upcoming generation, which will be more sensible to the climate change problem. I would say this, yeah.
Yeah, maybe one last point. It's just the fact that it's youth speaking to youth. It's a way to make them realize that they can act and they can go to school and share their views and share their willingness and what they want. And it's action, and empowering the youth is I think the best way to fight against climate change anxiety.
Great, thank you very much. I would just like to take the two last questions that were on the screens because the time is almost up. So the first one is, are there any open source platforms or toolkits you provide for educators to customize ocean data lessons?
That's true that for the time being, we do not have such customized tool or toolkits. These toolkits are more for young people, and we really try to make young people intervene into classrooms. That's the concept. And for sure, we are really open to organize even visio with educators or teachers to help them, because definitely what we realize is that in the curriculum there is not enough information on ocean. And usually when we intervene, when young people intervene, many teachers let us know that they did not know they did not know so much about ocean before, and they realize the lack in educational curriculum.
Great. And that's actually the last question I wanted to address to you, was about, is there any conversation around actually integrating these amazing ways of learning in the school curriculum? So I feel like you've kind of answered already. I don't know if there's anything else you'd like to mention.
I saw a question on the funding. So definitely it's a crucial question for us, and we really depend on the donation because all our awareness sessions are on a free of charge basis. So we go to school on a free of charge basis usually, and so we really rely on donations. So that's the way the NGO is funded, and we do not want school to pay for such awareness session because usually they can't afford it. So that's why our model is not so obvious, but it's the way we have decided at the beginning.
Okay, well, thank you very much to both of you for this great presentation and for answering all the questions from our participants. We might send you a few questions to answer after the event in written form because we received many. So thank you again for presenting the organization. And I think you mentioned as well you have an Instagram page. So don't hesitate to go follow this page for more information on Children for the Oceans as well. Thank you again, Stephanie and Marin, for the presentation. So we will now go to our next and last speaker, who is Yanis Androulidakis from the University of the Aegean, who's a professor and a physical oceanographer. And Yanis is going to tell us about how he integrates the Copernicus Marine data and tools into teaching, and especially related to topics of extreme weather and ocean hazards. So, Yanis, the floor is yours.
Thank you very much, Marin. Can you hear me?
Yes, we can hear you very well.
Great. Thank you very much for inviting me here. And I'm delightful to speak to such a large global audience. This is great. My name is Yannis Androulidakis. I'm a physical oceanographer and associate professor in the Department of Marine Sciences in Lesbos Island, University of the Aegean in Greece. And I will present some applications that we developed for the courses here in Department of Marine Sciences. I will, first of all, I would like to present some information about how we use Marine Service Copernicus data for our work here, both for research and for teaching. First of all, as physical oceanographers, we are very interested in the sea surface temperature data, satellite derived. This is for to investigate and study climate change effects and interannual variability, marine heat wave formations and variability, and also implications with biochemical and biological properties. And of course, we use this data for data simulation in our ocean and forecasting modeling. We also use sea level data also from satellites for many applications, especially for sea level alterations along the coast and implications with hazards like storm surges and coastal inundation and flooding, especially during extreme events. We also use sea level for investigating the ocean circulation and the interconnection between marginal seas, like in our area here between Black Sea and the Aegean. And we also, finally, we also use this for data simulation again in modeling. And ocean color data, like the ones that already presented before in this web seminar, chlorophyll concentrations. This is for implications between physical processes and drivers and biochemical, biological processes, and for river plume dynamics and also for biochemical modeling. And finally, we also use a lot of numerical data that are available in the Copernicus store, and these are related mainly to develop boundary conditions for our numerical simulations, both for hydrodynamic and biochemical, and also for Lagrangian numerical simulations for pollution applications, larvae dispersion, etc. And of course, these data are also used for investigation of vertical physical processes, because all the others are satellite and are mainly focused on study the surface of the ocean. And we also need information about the water column. So we use this type of data for this reason, for both, as I said, for research and teaching activities. But today I will focus on an example of a course that I have introduced the last semester. It's a new course in this in the program that I teach here in the university. And this is undergraduate level for the fourth year, the last year of the study. And you can see here the main components of the course, where we have lectures and computational applications in laboratory and computer laboratory, where students use software and available datasets, especially from Copernicus Marine system, and we use this they use this to assess their projects during this course. These are the main outcomes of the course. This, first of all, is to explain the dynamics of extreme and ocean atmospheric events, ocean atmosphere interactions, and hazards like storm surges. We also talk about tsunamis. There's another hazard. Of course, marine heat waves. And we analyze the physical mechanisms like the low pressure systems, atmospheric low pressure systems, the storm intensification, and we interpreted the real-time historical data sets. This is where the data from Copernicus came into the teaching activity. And the students also apply numerical modeling techniques and evaluate the vulnerability of coastal environments and infrastructure. They also discuss the influence of climate change. And we go now to policies, frameworks. We talk a lot about the usage and the development of early warning systems and the importance of them. And the important thing is that this is a course that synthesizes knowledge from different disciplines, like, of course, physical oceanography, but also topics from meteorology, climate science, and finally, coastal engineering for the solutions in the coastal zone. The students have to do a project. Each student has a study area that works on, and so they do assess independent investigations, and they also train in practical skills, the use of observational and remote sensing and modeling tools to monitor and predict extreme hazards. These are the main scientific topics: the storms and low pressure systems, of course, marine heat waves, both their physical mechanisms and the detection of these events, and also the impacts on the ecosystem. Coastal flooding and erosion, especially during extreme events. We also talk about climate change and the intensification of ocean hazards. For example, the intensification of storms. And we mainly focus on the Mediterranean Sea. And so we talk a lot about the tropical-like storms. We call them medicanes. These are storms, very severe storms for the Mediterranean Sea. We talk about storm surges and coastal flooding, and of course, the increase of marine heat waves, intensity and duration under climate change conditions. And finally, we talk about the mitigation, preparedness, and policy measures and strategies. And let's go now to the first application that I want to show that we do with the students during the semester. It's about the sea surface temperature and marine heat waves variability. The students have to download the sea surface temperature, especially the satellite from observations are available in the Copernicus Marine system. And they have to do a lot of statistical analysis and climatologies and define thresholds that they are going to be used for the detection of marine heat waves, based mainly on the methodology that was introduced 10 years ago by Hopeday. And so they learn all of this let's say, aspects, the climate variability in general, and they focus on extreme events. They also use different softwares and the codes for data processing. And of course, the most important is the physical interpretation. For example, how the temperature variability is related to other processes like stratification, heat fluxes, and air-sea interactions between the sea and the atmosphere. Each student has to choose a Mediterranean coastal region and gather all the data for his or her their region, like of course some topographic information, and of course for this temperature we use this product which is a relatively high resolution product. Is around 5 kilometers, and but it's daily, and it covers a long more than 40 years from 1982 until today. And first of all, they can use very simple tools like the Panoply software, which is available from NASA freely. It's an open software that can be used for both visualization, like this example here in the Northern Aegean, or also they can also extract data from this with this software for more processing. But we also develop some simple scripts with MATLAB or other languages, other codes, for more let's say in-depth analysis. So they compute several metrics, statistical metrics, and they do also some climatologies. They produce some climatologies. And finally, they can detect the extreme years during their time series, and also compute trends and the respective statistical significance. This is an example this is a coastal area in North Aegean. This is from a student's project. So you can see the different climatologies that this student produced, which is for different percentiles, for example, and also interannual variability for this region, where you can see the trend, the respective ascent slope. This is 0.04 Celsius per year for this area, and also other statistical metrics like find if there is a shift year where the time series shows a significant increase or decrease, a significant change. And they can also detect the most extreme year, where they can perform, like here, more analysis. This is 2024, which was a very warm year for the global ocean, but especially for the Mediterranean, it was significantly warm. Finally, they can they learn how to apply the detection of marine heat waves, an algorithm that we developed based on the methodology by Hobday. And this is an example. This is the number of events for the same area. And this is the cumulative intensity, which is a very important metric because it includes both the number of events and the intensity and the duration. So it's a more holistic statistical metric for marine heat waves, more information about these events. I'm not going to go to the details of the methodology. They can be found easily everywhere. Let's go to the second application that I would like to present. This is about storms, surges, and coastal hazards. This is an example of a storm. Here, the students, they use other sources together with the Copernicus Marine data. This is from the climate data store from Copernicus. This is the ECMWF ERA 5 for atmospheric conditions, and they use it to detect and get the atmospheric meteorological conditions during a storm that they choose that has affected their study area. This is Ianos, a medicane in 2020 that formed in the Ionian Sea and landfall in the western Greece with severe damages. In this case, we also go to the MyOcean Pro. We already saw this in a previous presentation. So the students can use this type of tool. This is an example. This is for the same storm, Ianos Medicane 2020. And this is before the storm, where they can draw here a line and get the information along the line. This line actually represents the storm's track. So each student has a different storm, different track. So they get different conclusions and results. And this is before the storm and shows how warm the sea was during the evolution, that this enhanced the intensification of the storm because they fueled, the storm got more energy. And we discuss this type of interactions. And this is the winds, this with the same tool from Ocean Pro. And this is finally during the storm. You can see the cyclonic wind conditions, and this is the detection, the response on the sea, the detection of cold wakes. This is a cold wake on the tail of the storm, and together with this data, they also trained how to use modeling data from Copernicus. This is the Mediterranean Sea Physics Reanalysis. This is the product which provides more information about the ocean. This is during the event. This is the sea surface height, which is very important during this type of events, especially when it landfalls. This is in the end of the track, where you can see the high sea surface heights along the coast. So it's important that they use this data together with other available sources. This is tide gauge data. This is sea level measurements along in many stations that are available online. And so the students have to choose a station that is very close to their study area. For example, this storm here, this station here during the same storm that I presented before, produced this increase in the sea level, and we compare this with the modeling data, so we can see if there are some errors in the data in the modeling simulations. And finally, the goal is to detect the inundation areas during the storm's surge. And so they use also ocean color data from the Copernicus browser. You can see here an example where they compute this index, which is very useful to detect areas on the coast that they have been probably have been flooded during a strong event like the one that I presented before. The white areas are the areas that before and after the storm that they probably were flooded during this storm. And they also use ocean and meteorological data together for long-term analysis. This is for many years, so they can do some trends with this data and also relate them to other data like climatic indexes, like North Atlantic Oscillation, and see the contribution of atmospheric conditions and climatological conditions on the response in the ocean. These are some examples. These are results from different students. This is for the North Atlantic Oscillation and the pressure over the study area. This is during a storm, the atmospheric pressure and the sea level. You can see the counter correlation between these two metrics, parameters. This is temperature and radiations, and this is interannual variability of pressure and sea level anomaly for the students' project. And finally, I would like to present another application that we do. This is using ocean color data and this is an example that we are trained in the course to detect the Black Sea water out. This is the North Aegean where you have the Black Sea water coming. And so we use this data to detect the spreading of these waters, which are high in chlorophyll, and we can also use them to detect pollution events because like the 2021 very strong mucilage bloom that affected a very large area. And so this is again with MyOcean Pro. This is the chlorophyll A concentrations for an extended Black Sea water plume spreading in the North Aegean. This is a limited case, and the students can use this together with
Okay, thank you very much, Yanis. Sorry, my camera was. So thank you very much for your presentation. We've received quite a lot of questions for you, actually, so I'm going to start sharing my screen straight away. Okay, so the first question is, I am studying marine biology in Greece. I really enjoyed your presentation. I would like to ask how reliable are satellite data in coastal areas? We can't hear you anymore. I don't know what happened.
Can you hear me now?
Yes, we can. Yeah.
Okay, sorry about this. This is true. Depending on the satellite data, for example, and their resolutions, there are some improvement the last years for the coastal satellite data, and that have improved their quality in the coastal zone. For example, coastal altimetry techniques, they have improved the sea level data that during the first year of the altimetry, let's say, era, that they were not very reliable because there is some noise from the land, contamination, and I would say that especially very close to the coast, this type of data have to be used with very careful way, let's say.
Okay, yeah, thank you very much. The next question is, I think this one was asked quite at the beginning of your presentation, so I think you kind of answered, but if you could repeat or tell us a bit more, which open source modeling tools are the students using?
Yeah, they can use, first of all, they use the Panoply, which is a software that is provided by NASA. You can find it also in the NOAA, the US service available for free. With this software, you can easily visualize your data, and you can export ASCII files from there. You can process them more with, for example, Excel or another open office software like this. And of course, but also we develop some codes and scripts in free software that easy ones that the students can use to process more their data in more in depth than it can be done with Panoply software. But also they can also use the online data, the software that are available with the service, the Copernicus service, that you can do quite a lot of visualization and sections, and which are very useful for the analysis and interpretation of the results and data.
Great, thank you. Next question is, are your lectures available on any MOOC platforms? Looks like
I'm not sure what MOOC means.
It's a massive open online course. So do you only teach at the university, or do you also develop teaching materials for online studies?
Yes, I have used some of this material for seminars and that I have participated in the past, but especially this course is a very new one. so it needs a lot of improvements. And I also learn from the students' feedback, because the last semester was the first one that I ever taught this specific course, especially with this structure. And these lectures are available in the e-learning class platform of the university only, so only the students that are here can access them. But I will be happy to share it if somebody can send me an email. And
Okay, great. Thank you for this. Actually, there's a question kind of related to, oh, I don't see it anymore, but the next question is, do you make use of recognition neural networks with the Copernicus data at all? Not sure I understand this question.
do you make use of recognition of neural networks? If I use neural networks with data, this is the question?
I'm not quite sure, but we could say that this is the question.
Not for the course, not for the class, but of course, yes, we use Copernicus data to train neural networks for many research activities, and like temperature to train a model for predictions, but not for teaching activities, not myself at least.
Okay, great. Thank you very much for your answer. So I think we won't have time to answer any more questions. The time is up already. So thank you very much for, and I feel like also some of the questions could need very long answers and could be kind of a course
I
of
will
their
be happy
own.
to answer offline later, send.
Thank you very much. Yeah, we will send you all the questions that we weren't able to answer just now. So once again, thank you very much for your presentation, for answering the questions. And I will just share a few more information before we wrap up the session. So once again, thank you very much to our speakers for your presentations today. We shared a lot of different tools, a lot of different information. So don't hesitate to have a look at the replay that we will make available on the Copernicus Marine YouTube channels a bit later today or tomorrow. I feel like this could be very useful to watch again. So you'll find the replay session also on the event website, as well as a link to the survey about this webinar. So please fill out the survey to let us know what you thought of it, whether you are already familiar with the Copernicus Marine service. If you've used the data before, this is very valuable information to us to make sure that we meet your needs in terms of training sessions. And if you'd like to go further after today's session, I encourage you to visit the Copernicus Marine Service YouTube channel, where you will find a rich library of webinars and training sessions from the past few years. They're all freely available, of course. And you can also discover all Copernicus Marine events, both upcoming and past, via the Events tab in the top right menu of the website, where you can find where you can open any event page for details and registrations. So I saw a question about whether we do only online training sessions. We do a lot of these. So this is where you will find information about all the other events as well, where the Copernicus Marine Service is participating or organizing. So thank you again for your participation today. If you enjoyed today's webinar, we encourage you to help us spread the word about ocean sessions by sharing your experience on social media. Don't forget to tag the Copernicus Marine Service in your post if you can do so. Thank you to everyone who attended today's event, and we look forward to welcoming you to the next one. Have a great rest of the day. Bye, everyone.